Welcome back, my beautiful grade 10s. Alright, the Lord has given us a beautiful new day, and let's jump into it doing some maths. Alright, so today we're going to be doing some proofs. Alright, so that's new in grade 10. Alright, so previous stuff. We've got some stuff that you guys have done in grade 9. Okay, so grade 10, you obviously need to know grade 9 stuff. Alright, so you need to know that maths is fun. Okay, your corresponding angles, your co-interior, and your alternate angles. You need to know straight lines, revolution, all that stuff. Okay, but I'm not going to go through that in the series. Alright, I'm just going to do the grade 10 stuff. Alright, so if you look at this here, we're going to do some proofs. Alright, so we are going to be proving, firstly, the first 3 proofs that we're going to be doing, okay, are going to be proving that certain properties of a parallelogram are true. Okay, so I'll say that again. So we're going to be proving that certain properties of a parallelogram are true. Okay, so by doing that, okay, we can only use the definition of a parallelogram. Okay, and the definition of a parallelogram is that both pairs, okay, both pairs of opposite sides are parallel. Right, that is the definition of a parallelogram, okay? And that is what we're going to be using for these proofs, okay? That's all I know about these parallelograms, okay, that I'm going to be seeing, okay? I only know, all right, that the opposite sides are parallel. All right, so let's jump into it. So look at the first one. All right, so we need to now prove that both sides of a parallelogram, of a palm, are equal, okay? I need to prove that property, okay? So the only thing that I know about this parallelogram, alright, so let me draw a parallelogram. The only thing that I know about that is that the opposite sides are parallel. That's all I know. Okay? And I now need to use that definition to prove that both pairs of opposite sides are also equal. So I'm using the definition of a parallelogram to prove the property. Okay, so that's what I'm going to be doing. Alright, so they're giving you. So it says that you may only use the definition of a palm, not its properties. Okay, so the definition of a parallelogram, we already know the definition of a parallelogram is that both pairs of opposite sides are parallel. So there they are. Okay, they're parallel there. Alright, and that's all I know. That's all I can use. Okay, I can't use anything about angles. I can't say that the opposite sides are equal. I can't say that because I need to prove that both pairs of opposite sides are equal. I need to prove that. I don't know that yet. Okay, so how are we going to do this? All right, so if I'm looking here, do we have any ideas of how we're going to do that? No ideas. All right, I assume. Okay, so first thing we're going to do is we are going to join line BD together. Okay, so we can say here, here's our proof. So construction first. Okay, so construction. Okay, so my construction is going to be, I'm going to join line BD together. Okay, that's my construction. That's what I'm constructing. I'm drawing that in. Okay, I'm constructing it. Okay, so if you look at this parallelogram now, okay, what do you see? Right, now I've split it in half. Okay, and what do you see? What do you notice there? Can you see that this parallelogram has now split into 2 triangles? Can you see that? There's the top one. Maybe highlight for you. Okay, if you can't see it. Okay, there's my first one. All right, there's the top triangle. Okay, and then I've got this bottom triangle over here. I've got 2 triangles here. Can you see that? All right. Now, those triangles, do they sort of look the same? They sort of look the same, right? All right. So, are they congruent though? What is the difference between similar and congruent? Okay, similar means that they are the same, but they're different sizes. All right, but congruent means that they are exactly the same. All right, are they congruent? I don't know that yet. Okay, but if I prove that they are congruent, what will I find out? If I prove they're congruent, let's see, watch this. Okay, if I prove that these 2 triangles are congruent, they're exactly the same. Okay, that means that line BD, Okay, those are equal to each other. Okay, in the two triangles. Right, then I'll prove that this side over here is equal to that side over there. Okay, by congruency, the two triangles. Right, and this side over here is equal to that side over there. So if I prove that these two triangles are congruent, I'm going to prove that the opposite sides of my parallelogram, both pairs, all right, are going to be equal. All right, so let's go and do that. I don't know that they're congruent, so let's go prove that they are congruent. Okay, so let's go see. All right, so we always start congruency. Okay, so let me see my proof here. We always start congruency with in triangle. Okay, so let's say ABD, right, and triangle CDB. Okay, now let's see what we have. Okay, so in these two triangles, what do I know? Do I know that the sides are equal? Do I know of anything about the sides? I don't know that they're equal. I only know that they are parallel. Okay, that's all I know. Okay, and what about line BD? Anything special about line BD? I know that BD is common. Good. Okay, so now we're getting somewhere. So I know that BD is common. All right. Anything else? Okay, I'll give you a hint. Look at the parallel lines. Is there anything that I can find that is equal to each other? I can say yes. Okay, look at the Z there. Maths is fun. Okay, we all say maths is fun, yes? There we go. Okay, so I can say that this angle over here is equal to that angle there. Okay, we'll give a reason now. Okay, so let's name that angle. So we say ADB. Okay, so ADB, this angle here, is equal to CBD. Okay, and why can we say that? Okay, because alternate angles are equal. And what are the parallel lines? AD parallel to BC. Very good. Right, anything else that I can find is equal? Anything else? All right, let's look here. This is parallel to this line over here. Right, and if we draw them and we connect them together, what do we see? We see a Z. Right, so can we see that this angle over here is equal to that angle over there? All right, do you see that? All right, now we're getting somewhere. All right, so now we can say CDB, okay, is equal to ABD, right, and we can say that again, alt angles equal, and we can say that AB is parallel to CD. All right, okay, so what do I have there? I've got a side, I've got two angles. So are these two triangles congruent? Yes, they are. And what is my reason for that? Good. Okay, so triangle ABD is congruent to triangle CDB, and we can say angle, side. Okay. All right. Now I haven't proven anything yet. Okay. I haven't answered my question. Okay. I need to prove that both sides of a palm are equal. Okay. So how am I going to do that? All right. So what are the opposite sides of that parallelogram? AB and CD. All right. So I can say here, therefore, AB is equal to CD. And why can we say that those are equal? Yes, by congruency. Okay, if you would like, you can say that triangle ABD is congruent to triangle CDB. You can say that as well. Okay, therefore, I can also say what other two sides are equal to each other. BC is equal to AD. BC equal to AD. And why can I say that? Bicongruency, same reason, bicongruency. Okay, or I can say triangle ABD is congruent to triangle CDB. Alright, I can close that. Alright, but I'm not finished yet. Okay, I just stated that those are equal. Therefore, what can I say? What did I prove? Here we go. Prove that both sides of a palm, prove that both sides of a palm are equal. Okay, both pairs of opposite sides, sorry. Okay, alright. Therefore, I can say both pairs of, sorry guys, both pairs of opposite sides of palm are equal. Alright, and there we go. There's your first proof. Alright, so let's just go through that again. Alright, so we see that we're gonna construct a diagonal here. Construct a nice diagonal. Okay, connect those. I see I've got two triangles. Right, I'm going to prove that they're congruent, because if they are congruent, all those corresponding sides are going to be equal. Alright, so if I can prove that, then that means that my opposite sides of my parallelogram are going to be equal. Okay, so therefore, both pairs of opposite sides of a palm are equal. Okay, so that's my first proof, guys. Done and dusted. Nice and easy. Alright. Okay, so if I look at the next one, here's number 2. So prove that both pairs of opposite angles of a palm are equal. Okay, so how are we going to do that? Okay, so we're given that. Right, remember, I can only use the definition of a palm. Okay, so do I know that this side is equal to this side and that that side is equal to that side? Do I know that? No, I don't know that, because I can't use any of the properties other than the definition of the palm. Alright, we may only use the definition, not its properties. Okay, so whenever you're doing these proofs, you cannot use the properties, only the definition. Okay, so how are we going to do this? How are we going to prove that both pairs of opposite angles of a palm are equal? How are we going to do this? Okay, so let me show you. Okay, so what we're going to do is we are going to let, here's my proof. Okay, so we are going to let angle B, let's say we let angle B equal x. Okay, so let angle B equal x. Okay, so what do we know about this parallelogram? The only thing that we only know that the opposite sides are parallel. Okay, so how is that going to help me find a value in terms of x for angle A over here? Okay, what are we going to do? We can say co-interior angles. Alright, we can use the co-interior angles there. Alright, so look here, there's my parallel line, there's my parallel line. Okay, and I'm going to connect those two, and automatically I see I've got a C there, or a sideways U, whatever you prefer. Alright, and what do I know about co-interior angles? What do I know about those? I know that if I add them up together, what do I get? They equal 180. Okay, so let's write that down. Let's see what happens. Alright, so we know that angle A, okay, plus x, okay, because we let angle B equal x. Okay, so angle A plus x is going to be equal to 180 degrees. And why can we say that? Because of co-interior angles. Right, and what's the parallel lines there? AD parallel to BC. Very good. Alright, now let's go find angle A. What is the value of angle A in terms of x? Alright, I'm going to take this x over, and we know that angle A is going to be equal to 180 minus x. Alright, so let's go put that in the drawing. Okay, that's going to be 180 minus x over there. Alright, now I want to see Okay, I want you to go and try and find out if you can figure out what angle D is going to be. Using the same method, see if you can find what angle D is going to be equal to. So pause the video, see if you can go do it. Alright, so I assume you've paused the video. Alright, let's go and see if we can do that together. Alright, so same way. Alright, I'm going to highlight my parallel lines again. So there and there. Right, and I'm going to connect those two. And there we go. There's my upside down U. Alright, so I'm going to use co-interior angles. And what do I know about co-interior angles? They add up to 180 degrees. So I can say angle A plus angle D is equal to 180. Okay, so angle A, okay, plus angle D is equal to 180. And why do I know that? Why can I say this? Because co-interior angles. Alright, co-interior angles. Okay, and what are the parallel lines now? Parallel lines are AB parallel to CD. Alright, or DC. Alright. Now, what is angle A equal to? Angle A is 180 minus X. Okay, so that's 180 minus X. Okay, plus angle D equals 180. Alright, now I'm going to take everything else that isn't angle D, because I want to go find what angle D is. Alright, so I need to go take everything else across. Okay, so angle D is equal to 180 minus 180, which is 0. And I'm going to take the x over, becomes positive x. So I'm only left with x over there. Okay, so I'll write it out for some of you who's a little bit confused. So the 180 stays. Take the other 180 over, becomes negative 180. And then I'm going to plus the x. Alright, and 180 minus 180 is 0. So I'm left with just x over there on that side. Okay, so that's going to cancel out. Right, and I'm left with x. Okay, now let's go put that in the drawing. So therefore x is equal to D there, angle D. Alright, and then I want you to go and do the same thing for angle C. So what are you starting to notice now? Can you guys start seeing that these opposite angles are the same? They're both x and x. Okay, so I'm halfway there. I'm almost there. Isn't that exciting? Okay, I'm almost there. I'm halfway there. Alright, because what I have to prove? Both pairs of opposite angles of a palm are equal. Now I've got one pair. Alright, so I need to go find the other pair now. Let's go do it. Okay, so pause the video, see if you can go do it. Alright, so I assume you pause the video. Let's see if you can do that. Okay, so we know that here's my parallel lines. So here it is, over there, and over there. Alright, and I'm going to connect those two. Alright, so there we go. There's my backwards C. Alright, so I know that angle D plus angle C, so angle D plus angle C is equal to 180 degrees. And why can I say that? Because of co-interior angles. Alright, and what are the parallel lines there? AD parallel to BC. Okay. Alright, now I know what angle D is. Angle D is X. I'm looking for angle C. I don't know what it is yet. I'm going to get it in terms of X just now. Alright, so to get C by itself, I'm going to take the X over. So angle C is equal to 180 minus X. Alright, there we go. Let's put that in the drawing and let's see what we have. Alright, so there I've got 180 minus X. Oh, and look at that. Isn't that beautiful? Right, that angle there, okay, is equal to that angle over there. So can you see that both pairs of opposite angles are equal? Alright, so I can state there, let me write that down. Right, therefore I can say that angle A is equal to angle C. Okay, and angle B is equal to angle D. Right, that we've proven. We proved it above. Therefore, I can say, what did I just prove? I just proved that both pairs of opposite angles of a palm are equal. Therefore, I can say both pairs of opposite angles of a palm are equal. Alright, isn't that beautiful, guys? Beautiful, beautiful, beautiful. Alright, okay. I hope that's making sense. Alright, let's move on to the next one. Alright, prove that the diagonals of a palm bisect the area. Alright, so I want you to cast your mind back to the first proof that we did. Alright, first proof, what did we prove? We proved that both pairs of opposite sides of a parallelogram are equal. Alright, and how did we do that? Okay, we split the parallelogram in half. We got two triangles and we proved that they were congruent. Why did we do that? We proved they're congruent because then I could find all the sides are equal. Alright, now if I prove again, I'm going to do the same thing. Now if I prove that both of those triangles are congruent, what do we know about the area of those two triangles? So let me move on to the next slide here so you guys can visualize it. So if I do the same thing as proof 1, I draw in my diagonal, right, and there's my two triangles. Okay, so if I can say that those two triangles are congruent, what do I know about the area of this one and the area of this triangle? What do I know about those two areas? They are the same. Very good. They are exactly the same area. Alright? So if I can prove that they are congruent again, then I know that the areas are the same. And do you agree that this diagonal will bisect the area of the parallelogram? Okay, it cuts the area of the parallelogram in half. Alright, so let's go and do that. Okay, so what did we do? Okay, so we joined our construction there. So construction. Okay, so what did we do? We joined BD. Okay, so we join BD again. Alright, so we join them, join our diagonal there. Alright, and now we're going to start with our proof. Alright, so same thing. Alright, how am I going to prove these two congruent? Okay, I want you to go pause the video and go do this by yourself because you guys should be able to do this already. Right? Okay, so I assume you've paused the video, you've done it. Okay, so I always start in triangle ABD and triangle CDB. Right, if I look at those two triangles, there they are. Alright, so is there anything there that I can say is equal? Yes, I can say that BD is common. There we go. Nice stuff. Lovely. Right? Anything else there? What else do you see is equal? Can you guys see the Z? Can you see the Z? So it's exactly the same as the first proof, guys. Exactly the same as the first proof. Okay, isn't that beautiful? Alright, so we can say that ADB is equal to DBC. And why can we say that? Alt angles. There we go. Alt angles. Right, and what's the parallel lines there? AD parallel to BC. Very good. Right, anything else there? Yes, of course. Okay, we've got the other alternate angles there. Alright, so there they are. Right, so that over there, okay, is equal to that over there. Okay, so now we can say that CDB is equal to ABD. ABD. Okay, and we can say alt angles again, and the parallel lines there is AB parallel to CD. Awesome. Alright, so now what do we know about those two triangles? We know that they are congruent. Okay, so we know that triangle ABD congruent to triangle CDB. Right, and why can I say so? Angle, angle, side. Alright, can you see it's basically exactly the same as the first proof there. All right, but I'm not finished, okay? Because what am I trying to prove? I'm trying to prove that the diagonals of a palm bisect the area. Okay, so what do I know? What do I know? All right, I know, let me write here. I know, therefore, I can say that the area of triangle ABD, okay, so the area of triangle ABD, here it is. Let me highlight it for you. So this triangle here, ABD. Okay, so what do I know about that area? It's equal to that area. All right, the area of the other triangle, this one here. All right, that triangle. Okay, can you see that? There we go. So area of triangle ABD is equal to the area of triangle CDB. Therefore, what do I know about the diagonals of a parallelogram? Therefore, diags of palm bisect the area. All right, and there we go, guys. There are my 3 proofs. All right, so just one thing that you guys need to remember, right? With these 3 proofs, all right, you can only use the definition of a palm. Okay, the definition of a parallelogram. That's the only thing you can use. All right, why? Because we are trying to prove that the properties are true. All right. Okay, I hope that's making sense. I hope that's cemented in your brain. Okay, because now we're going to be moving on to proving that something is a parallelogram, using the properties now. Okay, so these 3 proofs are separate to the ones that we are going to do now. Okay, so completely cut this off. All right, separate this from your mind. In your mind, separate these 3 from the next that we are going to be doing. All right, now we're going to be using the properties, okay, of a parallelogram to prove that it's a parallelogram. Okay, it's 2 different things. Okay, so here we go. So this is completely separate from the previous 3 things. Okay, so it says here, list 5 ways in which we can prove that a quadrilateral is a parallelogram. All right, so now we're going to be proving that something's a parallelogram. Okay, in these 3 proofs, we were proving that the properties of a parallelogram are true. Now we're just proving that a quadrilateral is a parallelogram. Very different. Okay, I hope you can see the difference. Okay, so we've got 5 ways. We've got both pairs of opposite sides are parallel. Okay, then second. Okay, so we've got the first one here. Okay, this is the first one. Then the second one here. Okay, both pairs of opposite sides are equal. The third one here. Both pairs of opposite angles are equal. The fourth one here. Okay, so this is a new one for you guys. One pair of opposite sides are equal and parallel. Okay, so what does that mean? Let me draw it here for you. Right, so there's my parallelogram. Right, basically just means that one pair of opposite sides are both equal and parallel. Only one pair. If you can prove that, then it's a parallelogram. Okay, and then number 5, diagonals bisect each other. That's number 5. Okay, so there's 5 ways to prove that something's a parallelogram. Okay, so let's see if we can do that together. All right, so here's some examples that I made for you guys, or that somebody else made for you guys. All right, so use one of these ways to prove that quadrilateral ABCD in the sketch below is a parallelogram. All right, so I look there. I look at this thing. It looks like a parallelogram. It smells like a parallelogram. It tastes like a parallelogram. I can hear that it's a parallelogram. I can see it's a parallelogram, but I don't know it's a parallelogram. I don't know it. I don't know that. Okay, so I can't say that this is equal to this, that is equal to that, because I don't know it's a parallelogram. I don't know it yet. Okay, so I need to first prove that it is one. Right, all I know is that it's a quadrilateral. All right, so let's look at what they give me. What do they give me? They give me angles. They only gave you angles. Alright? They gave you angles. Alright? Did they give you anything about sides? Did they give you anything about diagonals? No. Okay? So what is the only one of the 5 ways to prove that something's a parallelogram? What is the only one of those 5 that have something to do with angles? Let's go check. There's only one. Here we go. Angles. This is the only one that has angles. So which one do you think I'm going to be using? This one over here. Number 3. Fantastic. Alright. So, but now how are we going to do that? Alright. Can we see that we've got 4 angles? Different angles. Alright. And what are the interior angles of a quadrilateral equal to? The interior angles are equal to 360. Alright, so let's go solve for x. Okay, if I solve for x, then it's going to help me a whole bunch. Okay, so I can say here 2x plus x plus this angle over here. So that angle there is 90 minus a half x. Okay, then plus the 60 plus x. Sorry, not the 60 plus, yeah, 60 plus x. X plus 60 is equal to 360 degrees. And why can I say this again? What was my reason for that? Yes, some angle of quad. Some angles of a quad. Okay, so always put reasons, guys. Geometry is very specific. You always need a reason for stuff. Alright, so if I go and I do this, alright, so I'm going to add this all together. Alright, so over here I'm going to get 2x plus x is 3x, plus x is 4x, minus a half is 3.5x. Okay, so you can either write it as 3,5x or 7 over 2x. Okay, and then we've got 360. Alright, and we are going to take over the 90, so we're going to minus 90 there, and then we're going to minus the 60. Okay, and that's going to be 210 equal to 7 over 2x. Alright, and when I'm finding x, what do I have to do? I divide both sides by whatever's in front here. Right, so I'm going to divide by 7 over 2, and I'm going to divide by 7 over 2, right, and that should give you 60 degrees. X is equal to 60. Alright, so now I know what x is. Okay, so now let's go see what all these angles add up to. Okay, now that it's 60. Okay, so I know that angle B is going to be 60. That's an easy one. So I know that angle B is equal to 60. Okay, and what's the angle opposite angle B? This one over here, angle C. Let's just go find what C is. C, okay, is going to be 90 minus a half x, which is 60. Alright, and that's 90 minus 30, which is 60 degrees. Oh, fantastic. Can you see that this angle here is 60 degrees? That angle there is 60 degrees, okay? And these are opposite angles. Okay, so I've got one pair. Fantastic. How many pairs do I need? I need both pairs of opposite angles are equal. So I'm halfway there. Halfway there. Okay, so now let's check. Alright, let's check angle A. Angle A is equal to 2 times 60, which is 120. Fantastic. Alright, so that's 120 there. Nice. Alright, and let's go check angle D. Let's see what that's equal to. Angle D is 60 plus 60. Okay, x was 60, so x is going to be 60 plus 60. Okay, which is now 120 degrees. Fantastic. Alright, look at that. Right, can you see that that is now equal to that, which is 120. Okay, therefore, what can I say? I can say A, B, C, D is a palm. And why can I say that? What did I just prove? I proved that both pairs of opposite angles are equal. Okay, look at that. Isn't that just beautiful? Isn't that beautiful, guys? My goodness. Okay, so always check what they give you, guys. Alright, so a lot of guys, they wouldn't know how to even start this. Okay? But I see, what do I see? I see that they gave me angles. Okay? So now I think to myself, what is the only one of the 5 reasons that deals with angles? The only one. There's only one. There we go, angles. So I have to prove that both pairs of opposite sides are, both pairs of opposite angles are equal. And how do I do that? I go find for x, and I just substitute what x is, and I can find those angles, find them, and then we can see that the opposite ones are equal, therefore it's a parallelogram. Okay, I hope that's making sense, guys. Alright, let's look at the next one. Right, given that PQRS, okay, is a parallelogram, prove that O1 is equal to 90. Okay, so let's see that. Alright, so I want you to pause the video. I want you to think for yourselves, guys. Really, I want you to think for yourselves. Okay, because maths, it doesn't help if you wait for sir the whole time. Okay, you need to struggle to strive. Alright, so you need to do something yourself. Okay, so pause the video, see if you can do it. Alright, so I assume you've done it already. Alright, so they tell me, look here, they tell me, given that PQRS is a parallelogram, it is one. Alright, they're telling me it's a parallelogram. Alright, so what do I know about this shape? I know that both pairs of opposite sides are equal. Right, put it in. Boom, boom, they're equal. What do I know about the angles? The angles there, they're equal. Opposite angles are equal. What do I know about the sides? Opposite sides are parallel. Alright, so immediately, once they say it's a parallelogram, put all your properties in there. Okay, because it is a parallelogram. They're telling you, I don't have to prove it. Okay, but what do I have to prove? Prove that O1 is equal to 90. Alright, so let's go see if we can do that. Alright, so they give me x and x there. Alright, fantastic. They give me y and y. That's all they give me. Alright, so how are we going to start doing this? Right, let's see. So I know that these things are parallel, right? So I know that that's parallel to that, right? And if I connect this here, right, what do you see? What shape do you see? You see a U, right? Fantastic. You see co-interior angles. All right. So now how is that going to help me? Let's just write down what I know about co-interior angles. All right. Let's just write it down. Okay, because I know what co-interior angles are. I know that angle Q plus angle R is going to be equal to 180. I know that because I know it's co-interior angles. Okay, right, and I know that PQ is parallel to SR. Okay, so now how's that going to help me? That doesn't really quite do anything for me, really. All right, but I know what Q is. Okay, so let's go substitute in these values. Okay, so I know what Q is now, so let's see if it helps me. It probably won't. I don't know. All right, let's go see. All right, so x plus x is 2x, so I know that Q is 2x. There's Q. Q is 2x. All right, and I don't know what R is. Okay, but I can go just put in the letters. Let's see what happens. Okay, so y plus y, that's 2y. Okay, so I know R is 2y. Equal 180. Okay, so I'm getting somewhere, but I'm not really quite getting anywhere. Okay, so let's look at this. Let's look at this quickly. All right. So where is O1? Where is O1? O1 is where? It's in this triangle. Okay, can you see that? It's in this triangle here. Okay, right. O1 is in that triangle. All right. So what do I know about triangles? What do I know about the angles of a triangle? Okay, because I'm given angles here, right? I don't know that they're equal. I don't know that anything there is equal, right? But what do I know about the interior angles of a triangle? I know that they're all equal to 180. Okay, so I know that angle O1 plus angle OQR plus angle ORQ is equal to 180. And why can I say that? What's the reason for that? Some angles of triangle. Let me be specific because there's 3 triangles there. Okay, so OQR. Okay, some angle of triangle OQR. Alright, so that doesn't really help me, but what I do know that I know what those are. I know that OQR is X. So let me go put that in there. Let's see if that helps me. I know that that's X. Alright. And I know that ORQ is Y. Right? And that's equal to 180. So all I'm doing, guys, is I'm just putting down what I see. I'm just putting down what I know. Alright? I'm not really getting anywhere, but let's see. Alright, let's see what happens. Okay? I see that I've got X and Y here. X plus Y. Okay? Hopefully this is going to start ringing bells pretty soon. Okay, if it hasn't rung a bell yet, it probably has for some of you, right? But I see that I've got X plus Y here. And over here I've got 2X plus 2Y over there. Okay, I think some bells are ringing. Alright, so how am I going to get this to look like this? I can just divide by 2 here. If I divide by 2 on this side, I have to divide by 2 on this side. So if I divide by 2 here, I'm dividing by 2 everywhere. So 2x divided by 2 is just x. And 2y divided by 2 is just y. And what's 180 divided by 2? 90. Alright, so there I just found what x plus y is. Alright, I just found what x plus y is. Isn't that fantastic? What is x plus y? What is x plus y? X plus y is equal to 90 degrees. Okay, let's put that in. Let's see where it goes. Let's see what happens. Okay, 01 plus 90 is equal to 180 degrees. Wow. Now I can go find angle 01. Angle 01. Alright, I just take the 90 over. And what do we see? We see that 01 is equal to 90 degrees. Isn't that fantastic, guys? I just proved that 01 is equal to 90 degrees using geometry. Okay? And all I did, guys, is I experimented. Okay? I tried things. Trial and error. I put down what I know. Right? And I just formulated some things. I put things together and they all started to come together. Alright? But that will only happen if you guys actually try. Alright? A lot of you guys don't try anything in geometry, guys, and you don't get anywhere. Okay? You guys need to try things. You need to know what you know. Okay? And put it down on paper. See what you know. Put them together, and usually they just come together. Okay. Okay. I hope this video was good for you guys, and I hope it helps with your exams and your tests coming up. Okay, guys. Good luck.